Okay, we're going to start recording again and do some more stuff. So let's see. We did 1 and 2. Now we're going to do 3 and 4. Sorry about that. And let's take a look. So we need to get our patient data. So we're going to, let's call it Pat 1. Because that's just the way I do things. So we're going to have read table. File.choose, comma, header equals true, capital true, and patient 1, okay. Let's look at the STR, because I like to look at that. You don't have to. So there's your data set, not surprising. There's your Y, X1, X2, X3. So you're going to set up your LM object. You're going to have, what should we call this? Pat1.lm. And I'm going to do LM of Y tilde. And since I'm using everything else, I can just use tilde period, comma, data equals Pat1. So we're good. Summary of Pat1.lm. All right, what is our least squares regression equation? So it's going to be y hat equals 158.49 minus 1.14 x1. I'm kind of chopping some stuff off. Minus, I already have that. 0.442 x2 minus 13.47 x3. Okay, test the overall fit of the model. So what we will do here is say beta 1 equal beta 2 equal beta 3 versus not all beta sub I are equal to 0. And we need to get a p-value, and that goes out of the last line from summary, and that's going to be 1.542 e to the minus 10. So it's pretty small. Then we have our usual comment if p is less than alpha, then we reject HO. In this case, the HO is beta 1 equal to beta 2 equal to beta 3. And our p-value is very, very small. And our alpha was 0.5. It was given in the original question. Therefore, we reject HO. So even though we have two variables that are not significant, this is still a good model. Okay? Now let's look at testing beta 3. So we're going to test beta 3 equals 0 versus beta 3 not equal to 0. The p-value is equal to, in this case, 0.0647. So it's a little bit too large for 0.5. And we have our usual line here. If P is less than alpha, then we reject HO. So we fail to reject. Oops. Okay. Now, what is sigma epsilon? That sigma epsilon is really our residual standard error. Aha. We know what that is. It's 10.06. Okay. All right. Everybody okay with that? I hope so. Now let's take a look at question 4. So we take a look at commercial properties. We want to look at rental rates as our Y. As a function of age of the building. I don't know why my values got all funky here. Operating expenses, vacancy rates, and square footage. The data are in properties.txt. Please do the following. The usual data stuff, attach LM, test the overall fit of the model, let alpha equal 5, load library rcommander misc, and run the stepwise function on the LM object. What is the best model? Okay. So let's do prop assign read.table file.choose header equal capital true. Okay. And let's just do an str because it makes me happy. Alrighty. And we're going to create our LM. So let's just call it prop.lm. And we're going to do it on the whole data set. So we're going to have LM of Y tilde. And I'm going to use the period, comma, data equals prop1. And summary prop1.lm. Okay. So let's take a look at the overall fit of the model. We have 4 variables. So we're going to have beta 1 equals beta 2 equals beta 3 equals beta 4 versus not all beta sub I equals 0. Then the p-value comes from the last line equals 7.272 e to the minus 14. Our third line, of course, is the same thing. So we always have, if p is less than alpha, Then we reject HO. And so this value is very small, particularly compared to 0.05. What are we going to do? We reject HO. Okay. Now we're going to load library our commander miscellaneous. And we're going to run the stepwise function on prac53102. And our best model just takes out the x3. So prac2.lm is lm of y x1 plus x2 plus x4 data equals prop1, my fault. Okay, and if you look at the summary, okay, so the r squared is almost identical. The p-value is almost identical. And all of the variables are significant. So we are happy pups. Okay, good. All right, hope this helps.